Hello dear friends, this is the simplest and easiest way of teaching learning process in our most favorite YouTube channel Physics Make It Simple by Dr. Rajendra, now serving as a principal in Loknete Dr. Balasaheb Vikhe Patil, Padma Bhushan Awardee, Pravara Rural Education Societies, Mahatma Phule Vidyalaya and Junior College, Dad Budruk, Taluka, Rahata District, Ahmednagar. As long as 12th science oscillation is concerned, this is the lecture number 15, and in this lecture we want to discuss very funny article, dear students. That article is free oscillations, forced oscillations and resonance. Okay. Before starting directly, some of the students are conveyed me that whatever video, whatever lecture that I am delivering to you, that lectures are not seen clearly to you. That lecture or that video is blurred. To minimize this difficulty, my suggestion to all of you dear students, that if your mobile is vertical like this, make it horizontal at first so as to get a full screen video. This is the first thing. The second thing is that press the finger on the screen like this, then you will get such a type of symbol at right corner of the top, and press that symbol. You will get a 3 sections. The first section is that auto quality video. The second section is that high quality video, and the third section is that low quality video. Press high quality video at first, then it is clearly that whatever video you are seeing, that video looks like to be sharp, clear, more distinct, so that whatever content I have written on the board, it is readable to you and it is very suitable to you. Take a screenshot for your further study, dear students. Okay, so now we will start our actual article. That I have already told you that this is the funniest article of all. That is, what is free oscillations, what is forced oscillations, what is resonance. There are many types of questions are asked over this article. As long as your textbook is concerned, the textbook has given these 3 articles in a essay type. So I think it is somewhat difficult to you to understand all these 3 articles simultaneously. That I made that 3 articles point wise, and also by making use of a comparative study simultaneously with each other. It will make more easy to you how it is. Let us see. We will start at first free oscillations. For that purpose, I have taken a pendulum like this. Actually, I have taken a pendulum like this, and the body is displaced from its mean position, equilibrium position, and released. Then body starts oscillating with respect to its mean position. Such a oscillation is called as free oscillations. Such a oscillation is called as free oscillations, or it is also called as free vibrations. And the frequency with the help of which body oscillate, that frequency is called as natural frequency of the body. And so that such a free oscillation is also called as natural oscillation, because the body oscillates with its particular certain frequency. That frequency is called as natural frequency of the body. Okay, this is the first point. I have dictated you at first the definition of free oscillation. Then amplitude of oscillation depends upon 2 factors. Amplitude of oscillation depends upon the magnitude of force. The amplitude of oscillation depends upon the magnitude of force and nature of the body. What is the nature of the body? Whether the body is more elastic or less elastic, or whether the body is connected to a string like this. What is the nature of the body? It depends upon the nature of the body. So amplitude of oscillation depends upon magnitude of applied force and nature of the body. The most important thing in free oscillation is that, dear students, we apply force at a single time, only single time, and left itself to oscillate. I have displaced this body, this is a force, and left itself to oscillate. I haven't given any force to the body. So such a oscillation is free oscillation. Applied force is at a single time, body itself oscillate continuously with decreasing amplitude. Of course, because there is a friction between the string and rigid support. So friction between string and rigid support, and also what and the friction is there, and another thing is that what the another thing is air resistance. That means air is opposed to the body itself. Air is opposing to the body when the body oscillates. So these are the two factors: friction between rigid support and string, and the second one, air resistance. Because of that, amplitude slowly decreases. So damped oscillation is a type of free oscillations, and it oscillates with a particular certain frequency. We call it as natural frequency, and force is applied at a single time. So these are all points that I have already written on the board. I have also given the examples. The first example that I have demonstrated in front of you, that is oscillation of the simple pendulum. The second one, vibration of the prongs of the tuning fork. When tuning fork is hammered on the rubber pad and held in a one hand, then prongs of the tuning fork starts vibrating continuously like this. Such a oscillation is called as free oscillation. Vibration of the stretched string. Suppose this is a string and the string is plucked at the center, then string starts vibrating continuously. I have plucked the string at a single time. I have not applied continuous force. This is the most important speciality of the free oscillation. Remember, dear students, applied force is at a single time, not continuous force is applied. Such a oscillation is called as free oscillations. So read these points again and again, and after reading these points again and again, take a screenshot, and the question may ask you over this article, that is, write a short note on free oscillation. Then after learning free oscillation, we are going to learn now forced oscillation. What is forced oscillation? The title itself suggests that we are forcing the body. Dear students, do the study. But students are not wished to study. In the first case, if I will give an instruction to the student, dear students, close your books and notebook and go to the playground to play, that students are immediately running on the playground. I have given an instruction at a single time, but students are continuously playing on the playground. This is a free oscillation. Dear student, do the study. Students are not wishing to study. Continuously, I will have to hammer the student, do the study. Then and then only they are doing the study by making use of forced by the teacher. Such a oscillation is called as forced oscillation. So, after the application of periodic force, suppose this is a board and I have given a force periodically, then and then only the board vibrate. If the force is removed out, the vibration immediately stop. Vibration immediately stop. Because that board is not wishing to vibrate. I am forcing it to vibrate. So this is the first condition. When the body is subjected to the external periodic force, whose frequency is different than that of a natural frequency. Body is not vibrating with its natural frequency. The frequency of the applied force is different than that of natural frequency. Then body is vibrating, body is oscillating by forcingly. Such a oscillation is called as forced oscillation. To make a forced oscillation, we have to apply continuous force. I will give you another good examples which are from the beyond the book. When the aeroplane is moving over the roof of the hall, over the roof of the house, then as soon as the aeroplane is moving over the roof of the house, that roof starts vibrating like this. But as soon as the aeroplane went away, the vibration of the roof stopped. Roof is not wishing to vibrate. The roof is forcing by the aeroplane to vibrate. Such a vibration is called as forced vibration. Such a oscillation is called as forced oscillation. And suppose another example I will give you. Marching of the soldiers over the bridge. When the soldiers, as soon as the soldiers are marching over the bridge, that bridge is vibrating. But as soon as the marching of the soldiers stop, vibration of the bridge also stop. That means bridge vibrates by forcing the marching of the soldiers. Such a vibration is called as forced oscillation or forced vibration. Another example that I want to give you like this. When the train is running near the platform, as soon as the train is running near the platform starts vibrating. But as soon as the train ran away, vibration of the platform stopped. So, the most important thing, dear students, for the forced vibration, continuous force is necessary. Then and then only we get forced vibration. But most important thing, another most important thing of forced vibration is amplitude of oscillation is constant. In free oscillation, amplitude continuously decreases with respect to time. But as long as the forced oscillation is concerned, amplitude remains constant. And so that I have written here, during oscillation, amplitude remains constant. Amplitude of oscillation depends upon periodic force and difference between natural frequency and frequency of the periodic force. There is a slight difference between frequency of the periodic force and natural frequency. The difference is always remain there because the vibration is forced vibration. And amplitude of oscillation suddenly stop, that I have already explained, after the removal of external force. As soon as the train ran away, the vibration of the platform stopped. So, amplitude of oscillations suddenly stop when the periodic force is stopped, when the periodic force is removed out. And that example that I have already written, the periodic force is applied here, the force applied at a single time, here periodic force is applied. Examples that I have already explained in front of you, that is marching of the soldiers on the bridge, it vibrates. Aeroplane is moving over the roof of the building, it vibrates. Train is moving near the platform vibrates. As long as the MCQ is concerned, one sentence you should remember it always. As long as the forced vibration is concerned, That sentence is, amplitude is large if difference between natural frequency and frequency of the periodic force is less. If the difference between natural frequency of the body and frequency of the periodic force is less, amplitude of forced oscillation is large, and vice versa. So this is the most important sentence as long as MCQ is concerned. And then the last oscillation we want to discuss, that is resonance. So resonance is a modified form of forced oscillation. Actually it is a forced oscillation. Here also the body is forcing by applying periodic force, continuous force. But what happens in the last oscillation? There is a resonance between applied force and oscillation of the body. As soon as there is a resonance between student and teacher, then student will do a study regularly and you will get a best output. As long as the examination point of view is concerned, we call it as resonance. So there is a resonance between student and teacher. So same condition is happening here, that is, in forced oscillation the frequency of the applied force and natural frequency of the body is different, and amplitude of oscillation depends upon magnitude of the periodic force, and difference between frequency of the periodic force and natural frequency of the body. So there is a difference always remain as long as the forced oscillation is concerned. But in resonance what happens? In resonance what happens? When the body is subjected to external periodic force whose frequency is equal to the natural frequency of the body, then oscillation of the body is called as resonance. Or in short, in a simple sentence, when the frequency of the periodic force will match with the frequency of the oscillating body, then body vibrates with maximum amplitude, we call it as resonance. Earthquake is a good example of resonance. When the frequency of the earthquake will match with the frequency of the walls of the houses, then walls vibrate with maximum amplitude, and as soon as it vibrates with maximum amplitude, it will topple down. So this is a good example of resonance. So the next point is that amplitude of oscillation is maximum. Why maximum? Because the frequency of periodic force is equal to the natural frequency of the body. Frequency of the periodic force when match with the natural frequency of the body, then body vibrates with maximum amplitude. Such an oscillation is called as resonance. In forced oscillation, frequency of the periodic force is not equal to natural frequency of the body. The body is forcing, body is not oscillating with the frequency of the periodic force. But here, frequency of the periodic force becomes equal to the natural frequency of the body, and amplitude is maximum. Generally amplitude is maximum. During oscillation, amplitude also remain constant. Here also amplitude also remain constant, because we have to apply periodic force in both the cases, in forced oscillation and in resonance. So it can take place when frequency of the external periodic force is equal to the natural frequency of the body. Amplitude of oscillation slowly decreases after the removal of the external periodic force. In forced oscillation, amplitude of oscillation suddenly stop. But here, amplitude is not stopping suddenly. Amplitude of oscillation slowly decreases as soon as the periodic force is removed out. and periodic force is applied. Here periodic force is applied. Here force is applied at a single time. And that example that I have already given to you, example of earthquake, when frequency of the earthquake will match with the frequency of the vibration of the walls of the houses, then walls vibrate with maximum amplitude and ultimately it falls down. It is a type of resonance. When frequency of the marching of the soldiers will become equal to the frequency of the vibrating bridge, then bridge vibrates with maximum amplitude and it is possibility to topple down, then resonance is happening. So another best example is that when the frequency of the tuning fork will match with the frequency of the vibrating air column inside the resonance tube, then we get large sound as long as the resonance tube experiment is concerned. This is called as resonance. As long as the sonometer experiment is concerned, when the frequency of the tuning fork will match with the frequency of the string, the string vibrates with maximum amplitude and ultimately paper fall down. Falling of the paper from the string is a good example of resonance because the frequencies are matching. Frequency of the periodic force will match with the frequency of the vibrating body. Such an oscillation is called as resonance. So these are about 3 types of oscillations that you can compare simultaneously by doing comparative study, and there may be a possibility of asking different questions like this. Write a short note on free oscillation, write a short note on forced oscillation, write a short note on resonance. Then distinguish between free oscillations and forced oscillation. Distinguish between forced oscillations and resonance. Distinguish between free oscillations and resonance. So after learning these all 3 oscillations simultaneously and making a comparative study, you can easily write all the 6 questions very easily by proper understanding. In this way, dear students, this is the end of oscillation, and in the next lecture we are going to take next new topic or next new chapter, and we'll meet again in the next lecture. Be alert, remain to the physics, make it simple. Goodbye.